9E is all about variations. Not about the base, it's about the variations. We're going to set up and solve problems, including real-world problems, involving inverse variation, joint variation, and the combination of direct and inverse variations. We're going to start out with direct variation. The general equation for a direct variation is y equals kx. Just like all of your other equations, like y equals mx plus b. K is just like m. It's slope. We also, in this, we use k as your constant number you're using. So, getting into it, example 1, the amount of money raised at a charity fundraiser is directly proportional, so we know it's direct, proportional to the number of attendees. The amount of money raised for 5 attendees was $100. How much money will be raised for 60 attendees? There's always an initial statement that you're going to use to find your constant. Where you see directly, what comes before that is always your y. So this is the amount of money is your y. What comes after the words directly? Number of attendees. What comes after the words directly? There, that's your x. So the first scenario here, the amount of money raised for 5 attendees was $100. So for every 5 people, you get $100. You actually use, so we have to find k. So the first scenario is just used to find the constant. So the first scenario, we have the amount of money is $100. That's your y. And the number of attendees, 5. That's your x. So I'm going to put this into the equation. Y equals, not y. Y is 100 times k. You can make fun of my k later if you'd like. That's a k. And you multiply by x, which is 5, the number of attendees. And if you solve this for k, you divide by 5. What you're solving for is your constant. And in this case, the constant is 20. Now we're going to use that constant to solve the second part of our problem. We have how much money will be raised for 60 attendees. So 60 attendees, that's our x value, attendees, x. So put it in, we have to figure out how much money will be raised. Money is y, in this case. We have k, our k is 20, and we're multiplying by the x, which in this case is 60. So if there were 60 people that showed up, you would raise $1,200. That's a directly proportional. If there's only 5 people, it's 60. If there are 60 people, there are $1,200 we will make. That's a real world problem. Tough to say. Example 2. This is not a real world problem, but it's a problem that you might see on SOL. There's still 2 scenarios. The first one, if y equals 5, yx equals 2, that's the scenario you use to find your k. So we have 5 is the y equals k times 2. Well, solve for k, divide by 2, and k is an improper fraction, so that's fine, 5 over 2. We're going to use that in our second part of a problem. We're going to use the k, the constant. What is the y when x equals 10? So we don't know what y is. We do know that k is 5 over 2. And then we multiply by the x, which is 10. You multiply these out, you get 50 over 2, which is 25. So the y is going to be 25 when the x is 10. So that is direct variation. Now next we have inverse variation. Inverse variation, the equation changes up a little bit. It's inversely proportional. Y equals k divided by x. And k is still a constant. And y and x are just going to be involved in our problem. X is the independent and y depends on the x. So we look at the problem, the volume would be of a gas varies inversely as the pressure P on it. So it varies inversely. What comes before that is your Y. So the volume. That is your Y. You can put V in here if you want, since it does say V. What comes after the words varies inversely? That is your X. So same as direct. So the first scenario, there's always first scenario that's going to help you find your constant. First scenario, if the volume is 400 or 240 centimeters cubed, so the volume is 240, so that's your Y. Under pressure of 30 kilograms, that is your P of pressure, which is your X. This is going to help us find the K, the constant. That's going to help us find what the actual question is asking. So we have Y equals K divided by X. We're going to substitute in 240 for Y. You're going to substitute in 30 for X. Now you're going to solve for K. So this is divide by K, or divide by 30, so you multiply by 30. Both sides. And 30 times 240 is 7,200. And that's K. We're going to use that to find our second part of our problem, the actual question. What pressure has to be applied to have a volume of 160? Well, volume. See that volume? That's your Y. And what pressure? Pressure is P, that's the X, which we don't have. So we have to find, in our equation, 160 is our Y, K, 720, or 7,200, sorry, long day. And we don't know what X is. So how to solve for this? Well, you can't solve for an X in the denominator, so the only thing we can do is multiply by it. $60X divided by 160. Your X equals 45. And that would be the pressure that you'd have to have on a gas to have the volume would be at 160 centimeters cubed. Next equation, joint variation. Another equation. This is just Y equals K times X times Z. Again, same scenario. You have to, it'll tell you a first scenario, and this is if Y varies, so Y varies jointly as X and Z. Y equals 12, and we can just substitute that in. So 12 equals, X equals 9, Z equals 3, we don't know what K is. Always find K right away. This is like finding Waldo, but for math. Find K. 9 times 3 is 27, that's a K, I promise. Divide by 27. And we get K is going to equal 12 27ths, which reduces top and bottom by 3, which that's 4 ninths. So we're going to use that to find, now we have, this is our actual question of our problem. Find Z when Y equals 6 and X equals 15. So we know what Y is, so now Y is going to be 6. We're going to use our K that we found, 4 ninths. We put that in parentheses, times X is 15, times Z. We don't know what Z is. So I will do this in the calculator and get back to you in a second. Alright, so we get 6 equals 20/3 times Z. And you can either divide by 20/3 or multiply by the reciprocal. I haven't seen that in a while. Multiply by the reciprocal, 3 over 20, which, multiply this out, These will cancel, simplify, and this simplifies to 9/10. So the z in this case will be 9/10. Joint variation, just another equation. Use it just like inverse or direct. All right, last problem of the day, or night in your case maybe. Comment, we're going to combine the variations. So I've definitely seen released SOLs that are very, very similar to this. We have y varies jointly as x and w and inversely as the square of z. Now this sounds really crazy, but first thing we have is jointly. Y varies jointly, so y equals jointly as x and w. So it's a joint variation of y equals k times x times z. Well, instead of x and z, it's x and w. And then the second part, it's inversely. Inversely means divided by. So we're dividing by the square of z. So z squared. So now we use this equation for our scenario. So we have find the equation of variation when y equals 100, x equals 2, w equals 4, and z equals 20. Substitute these all in. So y equals 100 equals k, we don't know k, times 2, times 4, divided by 20 squared. So let's start simplifying this. 100 equals 2 times 4 is 8, so 8k, divided by 20 squared is 400. And now multiply by 400. And simplify. 8k equals, not a very nice zero, it's a 40,000. And then you divide by 8. Divide by 8. 8k equals 5,000. K is going to equal 5,000. So, to get back to the actual question, let's find the equation of variation. The equation is this equation here, but just substitute in k. So y equals, we found k to be 5,000, x w over z squared. So that is our general equation for this problem. Come to class with any questions you have on any of this. We're going to do a pretty extensive worksheet. Ask lots of questions. I will be glad to answer them. All right.